Here we're going to solve different kinds of equations, and though this is not exhaustive in the different types of solving techniques, this will show you a lot of different things that you should be exposed to. This first example is pretty simple because these are actually linear. So what I mean by that is my variables, which are the w's, are all to the first power. So when you have a linear equation, you want to get all the variable terms on one side. So here, what that means is I have 3w plus 5. Let's distribute that 2 first. So I distribute the 2, I get 2w plus 6 minus 4. Now let's bring all the w's on one side. So if I subtract 2w from both sides, I get 1w on this side. And I subtract 5 from that side, I have 6 minus 4 is 2 minus 5. So I get w equals negative 3. I went through that kind of fast, but you should have some exposure to linear equations. If you need further help, just let me know. Alright, for the second equation, this is a little more involved, but not too much more. So here, what I want to do when I have these rational expressions, I want to factor. I want to see what I'm working with. So my numerator, I can factor out a common factor of x squared, and I'm left with x plus 3. The denominator here, I need two things that multiply to give me negative 3 and add to give me negative 2. How about x minus 5 and x plus 3? On this other side, I have 4x plus 5 times x minus 5. Okay, now, one thing we should point out is it could be a domain issue here. We can't have zeros in the denominator, so we need to make a note here that x cannot be negative 3 and 5. Those are not possible solutions. Alright, now continuing, what I'll do now is multiply both sides by, well, actually, what I notice, first of all, is that the x plus 3's cancel out. So I'm left with x squared over x minus 5 equals 4x plus 5 over x minus 5. How about I multiply both sides by x minus 5? And when I do that, it's going to cancel out these denominators. And so I'm left simply with x squared equals 4x plus 5, which is just a quadratic equation. For quadratics, you want to get 0 on one side. So for quadratics, and actually for higher power equations, you set 0 on one side and factor. Okay, so now I have x squared minus 4x minus 5 equals 0, where I subtracted everything over. And now I just got to factor this guy. That's going to be, I need two things multiply to give me negative 5 and add to give me negative 4. How about x minus 5 and x plus 1? So now when I solve this, I get x equals 5 and negative 1. Oh, but we have to remember we had a stipulation here. 5 is not a valid solution, so my only solution then is x equals negative 1. Great. Alright, moving on to the next one. This is just a simple quadratic equation. So we just have to bring everything over. So I have x squared plus 7x plus 12. And I like to write my terms in what I call descending order. So from highest exponents to lowest exponents. And now I just need two things to multiply to give me 12 and add to give me 7. So I think we can see after some time that that would be 3 and 4. So then my solutions are negative 3 and negative 4. Pretty straightforward. For part D here, we have 4x squared minus 4x minus 27 equals 3. This is quadratic as well. So again, we want to get 0 on one side. So I'm subtracting 3 over. So negative 27 minus 3 is a minus 30 equals 0. From here, we could try factoring, but I'm going to use the quadratic formula. So for the quadratic formula, if you have ax squared plus bx plus c equals 0, the solutions of this are going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Generally, I don't encourage memorization, but this is something that you should memorize. Alright, so recognizing here that 4 is a, negative 14 is b, and negative 30 is c, I plug into the quadratic formula, and I get x equals 14 plus or minus the square root of b squared, so that's negative 14 squared, minus 4 times a, which is 4, and c, which is negative 30, all over 2 times a, which is 2 times 4. So that is, after simplifying a little bit, plus or minus the square root of 676 all over 8. Okay, and it just so happens that the square root of 676 is something that we can deal with rather easily. That's 26 over 8. So my two solutions then are x equals 14 plus 26 over 8, which is the same thing as 40 over 8, which is 5. That's one solution. And my other solution is x equals 14 minus 26 over 8, which is the same thing as saying negative 12 over 8, which simplifies to negative 3 halves. So my solutions then are 5 and negative 3 halves. Okay, moving on to part E. I have y to the 4th power plus 21y squared minus 100 equals 0. Now this is a 4th order polynomial, which can sometimes be very difficult. This one's actually not. So anytime that you have this pattern, you can factor this, because what I could do is say, well look, let's let u be y squared. Okay, if that's the case, then this equation turns into u squared, right? Because y squared squared is y to the 4th. This is y squared squared. So I get u squared plus 21u minus 100. So then I can factor that as two things that multiply to give me 100 and add to give me 21. How about 25 and negative 4? Okay. Oh, and that's not, I'm sorry, that's not u squared here, that's just u. But now turning it back into y's, this is the same thing as saying y squared plus 25 and y squared minus 4. And I can actually factor the y squared minus 4 as y minus 2 and y plus 2. It's the difference of squares. This is the difference of squares. Now, you cannot factor in the real numbers, you cannot factor the sum of squares. So here, my only zeros then, this will never be 0 in real numbers. So my only reals are y equals 2 and negative 2. And generally in calculus, we only consider the real numbers. But mathematics can get more general than that. Okay, now for part F, I have 2 times the absolute value of x plus 1 equals 18. Okay, so when you do these, first you want to try to isolate the absolute value if you can. So here I have square root of x plus 1 equals 18 divided by 2 is 9. Alright, now what absolute value means is distance from 0. Right, so if I have a number line, here's 0, here's 5 and negative 5. Both of these have a distance from 0 of 5 units. That's why the absolute value of negative 5 and the absolute value of 5 are both 5. Alright, so this time we need to consider any unit that is distance 9 from 0, my unit being x plus 1. So what I do is actually break this into two equations. X plus 1 equals 9 and x plus 1 equals negative 9. Both of these would be distance 9 from 0. So my first equation, I just subtract 1 and I get 8. The second one, I subtract 1 and get negative 10. So there are my two solutions, negative 10 and 8. Our last example today is in G. Is 4x equals 3 minus x to the negative 1/2 power minus 3 times the square root of 3 minus x equals 0. And this is definitely the most confusing of all of them. And I think what would be useful is to remember that the square root of 3 minus x is the same thing as saying 3 minus x to the 1/2 power. So what I'll actually do here, so let me rewrite this. I have 4x times 3 minus x to the negative 1/2 minus 3 times 3 minus x to the 1/2 equals 0. What I want to do here is I'm going to multiply both sides of my equation by 3 minus x to the 1/2 power. Okay, so why this is useful is because when I distribute across on this side, something special happens. I get 4x times 3 minus x. Now I need to add the exponents to the 0 power. Negative 1/2 and positive 1/2 add to give me 0. Then I have minus 3 times 3 minus x. I have to add the exponents. So it's 1/2 plus 1/2. That's the first power. And on this side I'm multiplying by 0, so nothing changes. Now anything to the 0th power is 1, so I end up with 4x minus, and anything to the first power is just, well, to the first power, so that's 3 times 3 minus x equals 0. So I get 4x minus 9 plus 3x equals 0. So I end up with the linear equation 7x equals 9, or x equals 9/7. And there it is. Okay, thank you for watching. If you have any questions on any of this, please let me know. I'd be glad to help. And algebra can be tricky, but if you're just consistent with it, you can get it. Thank you.